Parametric equations and graphs. Today what we're going to talk about is the plane curve from a parametric equation. A parametric equation are equations of x and y that are functions of t, which is the parameter. For t in the interval I is going to give us a direction of our graph as well. Usually over time, our third variable usually is t, but that's what it is, it's over a third variable. So in this case, we've got x equals t squared minus 2 to tell us where the x portion of our graph is, and y is equal to t plus 1 to tell us the y portion of our graph. And we're only going to graph t values from negative 2 to 2. So what we're going to do is we're going to make a t, x, y table. And we're going to want to remember what x is. X is t squared minus 2, and y is t plus 1. So what we're going to do is we're going to make a t, x, y table, and in t we're going to put values from negative 2 to 2. So let's go ahead and do negative 2, negative 1, 0, 1, and 2. Extend our line on down, and go ahead and find some values. So if we put a negative 2 in, negative 2 squared is 4. 4 minus 2 is 2. Negative 1 squared is 1. Minus 2 is negative 1. 0 squared is 0. Minus 2 is negative 2. 1 squared is 1. Minus 2 is negative 1. And 2 squared is 4. Minus 2 is 2. There's some symmetry going on there. Over here, negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. So we now have our ordered pairs that we're going to end up plotting here in a second. We're going to have 2 comma negative 1. We're going to have negative 1 comma 0. We're going to have negative 2 comma 1. We're going to have negative 1 comma 2, as well as 2 comma 3. But the thing is, as we plot these points, we want to look as t goes from smaller to larger. As we're going this direction as we plot, we're going to put arrows on our graph. So our first point's at 2, negative 1. It's right here. And notice up here it's or equal, so I'm going to put a solid dot right there. Our next point is negative 1 comma 0, so negative 1, 0 right there. And then negative 2 comma 1 there. And then negative 1 comma 2. And notice the direction we're going here. And then finally 2 comma 3. And that endpoint does not equal, so I'm going to put an open circle right there. Now as we did the graph, you'll notice our graph went in this direction. So we would put arrows to indicate that so that we know the direction of our graph as well. So this right here is our plane curve by the point plotting method. We did a t, x, y table, and then we plotted the points in order as t goes from smaller to larger values, giving us that. Now the next thing we can do here is we can change a parametric equation back to a two-variable coordinate plane equation. And all it takes is substitution. So what we're going to do is we're going to look at our two equations here, and we're going to decide which one can we get the parameter, t, our third variable, alone easiest. Is t squared minus 2 going to be easier to get t by itself, or is t plus 1 going to be easier? You got it. T plus 1 is going to be easier. We're going to do that by moving the 1 over here with subtraction to cancel it there. So we're going to be left with t equals y minus 1. And all we're going to do is substitute that in place of the parameter, in place of t in the other equation. So down here we're going to get x equals t squared minus 2. But t is equal to y minus 1. So y minus 1. Now, what we can do is we can go ahead and add the 2 on over there, and we would have x plus 2 equals y minus 1 squared. And there you've got your standard form of the equation. Or what we could do is we could go ahead and square this and simplify it all out, realizing that we would have x equals y squared minus 2y plus 1 minus 2, which would actually equal y squared minus 2y minus 1. Now, this equation here is the same as this graph, but it doesn't give you the direction of order, the arrows, and it also doesn't limit the domain for you, which we had right here where our parameter was limited. So you'd have to look at that. If you were going to change it to this graph equation, you would need to look at what is your parameters restriction, and you'd have to restrict the domain to make that correct. So we'll talk about something like that in the next example. Hope this helps out, folks. Have a good one. I'll see you in the next video.